right? So there is something called stereoisomerism, right? Stereoisomerism, if you break into two words, so otherwise you will face difficulty in pronunciation. This is stereoisomerism, all right, which means same molecule, right? Same molecule, but it will look like you place a mirror in between. If you place a mirror, so say for example you are standing in front of a mirror, your right side will look like left side and left side will look like right side, right? So similar scenario here. This is stereoisomerism. So what I have is C2H3R, right? This R can be a ClO, F4, whatever it is. That's a double bond, right? So you know, while breaking the double bond, we will put something like this in both the sides, and we will break the double bond. There will be not double bond, there will be only single bond, right? So this is this. You see, C2 is there, H3 is also there, R is also there, and double bonds, right? Oh, you can write the same thing in the other way, right? You place a mirror, right? You place a mirror this way. I place a mirror this way. So what will happen? These two will be here, these two H will be here, these two carbon will be here, and this R will go there, and this H will also go there, right? So this and this are similar things. You see, two carbon, two H, one H and one R, one H and one R. So if you place the mirror here, you will have structure like this. Okay. In a similar way, you place a mirror here, right? You place a mirror here. So A will be there, this E will be here, this D will be here, and this B will be there, right? So same structure taking different orientation is known as stereoisomerism, right? Stereoisomerism. And also, if you look at this diagram, so there are two strange lines and two kind of different lines. Did you observe? These two are kind of similar lines, and these two are even different. The reason is, right, this is a 3D model, right? The previous slide I show you, this is a 3D thing. So this in nature, you see, in nature this will hold a volume, not a line. Right? In nature this will hold a volume. Volume means that is 3D, right? In 3D, if I draw all the lines as same like this, how do I know where is it standing? Maybe it is staying in this plane. Maybe this R is not in this plane and it may be inside this plane. Maybe this H is not in this plane but maybe in front of this plane, right? So these things are possible since it is taking a volume. So this is to show that, right? So one of this is to show it is staying before, I mean in front of the screen. One is to show it is in the back of the screen. These two are not in this plane of the screen, right? A, B and D, E are not on same plane. A and B may be on same plane. E and D are not on the plane. So either it may be E on the back of the plane and D on the top of the plane, or on the other hand, that has a particular reference, right? To if it is going inwards, it is staying in front or inside. If it is going outwards, so there are standard reference for that, right? How to draw the arrow mark for denoting the plane. This is why we have lines, different lines. Okay. This is how the molecular shape and the stereoisomerism is. Stereoisomerism means you place a mirror in front and how will it look like? This is what called stereoisomerism.